Welcome everyone. This is the Light Brigade, and we are presenting a fifth in our series of webinars that we are hosted by Lightwave Online. I'd like to thank Stephen Hardy and his entire crew for hosting these programs. Our presenter today, as in our last few webinars, is Larry Johnson, the director and founder of the Light Brigade. And I want a couple of housekeeping things I want to clear up before we get started, and in particular about asking questions. We want to be sure to ask questions. You have a box in the lower left-hand corner where you can post questions. If you have technical questions, we have a technical team online to take care of those for you. If you have questions about safety and the webinar in general, we will list those questions and then answer them at the end. If we're not able to answer your question in the time allocated, we'll be sure to respond back to everyone via email later. This webinar will be hosted at Lightwave Online, and it will be available for viewing tomorrow after 24 hours. And you will be able to also go back if you want and look at some of the previous webinars we have done. One question we always get asked that I'll cover ahead of time is that we don't offer these PowerPoints as downloads. These are all proprietary information we use for our classes, but you can go back and review them as often as you want on Lightwave Online. We're going to make a special offer at the end of this webinar about our safety DVD, which is really the foundation of this presentation, but it's much longer when you buy the DVD. There'll be a 20% savings available, and we'll give you a special passcode for that at the end if you want to acquire that. I want to turn this over to Larry Johnson now, and he'll do a presentation.
Hi, everyone. Thanks for joining, taking out a little bit of time. As Jim mentioned, we developed a DVD on fiber optic safety and had to hold it up actually for about a year because we were waiting on some of the standards to be released, which we're going to talk about in this presentation. On this first slide, we're going to basically cover these categories: lasers, chemicals, adhesives, fibers, for those involved with installation, and then basic safety procedures in organizations. And I also want to expand on this a little bit more and just talk about perspectives, because we have a lot of different people participating today. And the perspective of a laboratory or a manufacturing environment is different than a user environment or an installation organization. So do think about it from your perspective, and I do welcome questions and look forward to getting those questions. So in the safety issues we're going to discuss, the wide variety of hazards exist, and they exist in different applications which are listed. There's also regulations put out by different organizations, and unfortunately we can't list all of them worldwide, but in the United States, OSHA in particular, which develops and enforces workplace safety in the United States, and this applies to any of the upper categories. And then at the same time, we have organizations responsible for lasers themselves and regulations, such as CDRH. Part of this perspective I'm talking about, though, is the development of a safe work environment at work, and that's part of an attitude, and this starts from management down to the workers, and making sure that a safe workplace exists. And we're going to cover national and international safety standards that apply to many of these topics. Okay. First thing, the laser now is 53 years old. May 16th of 1960 was the anniversary of the first laser by Ted Mayman, and laser is one of the critical elements in a fiber optic safety program, because most fiber transmitters and pieces of test equipment actually use laser diodes. And so there's different types of lasers, the distributed feedback laser, DFB, there's a typo there, the Fabry-Perot laser, and the vertical cavity surface emitting lasers, and these are all used in communication systems. But we also deal with optical amplifiers, of which the erbium dope fiber amplifier, the Raman, and the semiconductor optical amplifier fall under these categories. There are other types, specialty types, but these are the three most common out. And then when you deal with laser, you have to deal with the effects of the coherence, the power level, the optical power level, and the beam itself. And this can also be combined with the fiber type, which then we would apply the core size and the numerical aperture or mode field diameter. And then the types of control measures that are implemented in the use of laser or laser transmitter. And again, reminding that some people here work with laboratories or in manufacturing environments where they could be working with a laser diode as a component versus those that are using them as part of a system element. And when we deal with lasers, we're predominantly concerned with eye and skin safety, with a major focus on eye safety. So working with lasers, the key element, again, is where would someone come in contact with the output beam of a laser. And this is inspecting fibers or connectors, and we'll talk specifically about some of the different types of inspection scopes that are available. But we are looking at the output of a fiber and then how it reacts to the eye. Anybody that's involved with fiber preparation, if it's terminated to a, say, an OTDR port during an acceptance test or an emergency restoration or development of a product which is being monitored live, such as manufacturing possibly of optical FBT couplers, for example, and that. Transmitter ports on system optoelectronics. Pay extra attention to ribbon fibers, because in a very small area you can have 12 fibers in a ribbon, and then on top of that you can have maybe 40 different lambdas transmitting optical power in a case of, say, a DWDM system operating at 50 gigahertz spacings. And then you put those in one connector, such as the MPO, MTP types, And then the optical test equipment, different power levels and different pulse widths with different power levels that are required, light sources. Safety to be concerned about for public access, and there's features, for example, on fiber to the home or the optical network terminal. The laser automatically shuts down if it's disconnected, and we'll talk a little about that. And then the visible lasers, and a lot of these people look at for toys or so, or pointers and such, and the lower the wavelength, the shorter the wavelength, I should say, the more danger there is as far as the wavelength itself is. And then on the chart we see the diagram of an eye, and it's, for the most part, we have the surface of the eye, and then we have the retina of the eye we're concerned with. So when you're inspecting a connector or a fiber, we recommend that the laser is turned off during these inspection criteria. So fortunately, most lasers used in fiber optic communication systems, and by the way, that acronym FOCS you're going to see in the industry quite a bit more, but most of these lasers are considered Class 1 lasers. Class 1 lasers are specified by the IEC and the LIA in two different standards, which we're going to give you, along with power levels, et cetera. But they're considered retina safe because of their low power levels. We don't like to hear the word eye safe, and we need to be a little more specific. But again, the recommendation is not to look into the end of the fiber or the end of a connector. So fortunately, because of these Class 1 lasers, we don't have problems with this occurring. I mentioned earlier that we held up the safety DVD for a while, and part of the reason was this, the ANSI Z136.2 standard, which is titled The Safe Use of Fiber Optic and Free Space Optical Communication Systems Utilizing Laser Diode and LED Sources. The standard has been in committee literally for a few years, and we had access to that standard during those processes and paying attention to the classifications and changes from the previous 1997 issue. But this issue was finally released last December. I do recommend that anybody that's using fiber optics do order this standard. It's relatively inexpensive. I believe it's like $80 or so. Easy to acquire and review. One of the big differences, of course, is the title in the free space optical communication systems, which is just a point-to-point system, somewhat like a microwave system, but it does use fiber optic lasers, and but you don't need an FCC license if you're going to implement these. The previous standard, or not the previous, but the ANSI Z136.1 standard, which defines all the laser classifications for the United States, tells us if it's a Class 1, Class 2, Class 3, Class 4, and defines what those are. So in one case, it's good to have the Z136.1 standard, but for those in fiber optics, definitely the Z136.2 standard. And then the OSHA also has a standard for laser safety, which is listed down below. And the international standard, the IEC 60825-2, basically came out before the ANSI Z136.2 standard and provided the guideline for it and a lot of the values and the classifications. It was released earlier than the ANSI standard. Very parallel, but for those that are outside North America, you may want to order this standard as well, or if you are dealing with products from overseas or so that may reference this. And like the Z136.2 standard, there's the prior issue, which is the -1, which also defines the laser classifications. In addition, the ITU, the International Telecommunications Union, also has a series of standards that call out safety issues, and the G39 supplement, Optical System Design and Engineering Considerations, is one of those. And it talks about best practices, including viewing fibers. In this case, we use the international spelling because it's an international standard. Signage, alarms, viewing equipment types of terminations, and the impact of cleaning of connectors and optical amplifiers, which we'll expand on later because of the higher power levels being used. Another standard is the G.664 standard from the ITU, Optical Safety Procedures and Requirements for Optical Transport Systems. And this one provides guidelines and requirements for those who are working around transmission equipment and optical interfaces. It expands and includes Raman amplification techniques in restricted and controlled locations. In most cases, the restricted would be where you don't have access to the laser itself, and then controlled is just that you have a controlled mechanism. A non-controlled access location really applies for free space optics versus controlled. And in particular, it went into details on the dense wavelength division multiplexing systems, which can have large channel counts. I mentioned before 40 different lambdas over a single fiber. And it also provided guidelines for manufacturers on automatic power reduction, automatic laser shutdown, automatic power shutdown for systems that use Raman amplifiers as well. And this goes backward down to conventional SONET SDH systems, but it really doesn't matter if it's a SONET system or an Ethernet system. It's still the output power of the source and how they're being multiplexed together. Another document from the IEC is the TR 61292-4, Optical Amplifiers Part 4, which gives the maximum permissible optical power for damage-free and safe use of optical amplifiers. And this one describes fiber damage caused by high optical powers. And we're talking about fiber damage. We're talking about that the end face of the fiber can be damaged, but we're also seeing where contamination on connectors can cause damage on the end face of those. Mostly these are induced by dust and contamination, which is why it's critical to keep your connector interfaces clean to prevent damage in the first place, optical damage, and reduce reflections, but also these high power levels to reduce in-face damage of the optics themselves. A couple bullets down, you'll see another item that's talking about fiber coat burn melt induced by macro bends. And this is occurring because of just a case where we're showing a patch panel here where you see jumpers being bent. If they're too tight on these bends where there's enough optical power to actually cause the fiber coating to burn, the Kevlar and jacketing to heat up, and that with that much power. So again, this is one of the reasons why we need to have this automatic power reduction and automatic shutdown features built into high-power systems so that if somebody disconnects a connector in the field or at a cross-connect panel, that they will not have any type of eye damage or skin damage caused by these effects. So you really need to pay attention to some of these specifications and then cross-check with your vendors who are supplying products to making sure that these benefits of APR and APS are built into their transmission products. And the higher speed and the higher fiber counts and the more amplification that we're dealing with is more critical to consider these. So when we start talking about fiber optic systems, then we start also looking at some of the equipment that's out and some of the findings you have. So, for example, optical power measurements and equipment issue, the power thresholds. If you're having let's say you're a CATV operator and you're running an EDFA laser, a Class 3B laser in your system, most power meters that are sold in the industry do not accept that much optical power. So you need to specify and make sure you understand the wavelength sensitivity and the power sensitivity of the photo detectors on these power meters. So pay attention to the specification. So if it says it's a plus 5 dBm to minus 60 dBm power meter, that's going to be unacceptable if your output power is plus 15 dBm. It's only going to display the plus 5. So you need to make sure that your specifications are correct and you're putting the right equipment into the right user's hands. And in regards to inspection scopes, there's two basic types that are used in the field, the microscopes and the digital scopes. My experience with the microscopes is all those that are at 200 power magnification and greater have a built-in laser filter to reduce, step down the attenuation level to the eye. And normally this is about 30 dB, but again, ask your supplier to supply the chart to you, and that's so that you have it available. I just had one sent to me the other day that was quite impressive from a manufacturer. And it showed the different wavelengths and how much the safety filter reduced the optical power levels. So those are good. On the other side, the digital scopes, you're really not looking at the light. What you're looking at is an image that's captured and displayed. So it's basically a TV system, and you're looking. So those are eye safe to use in this case. Plus, there's also the added benefit where you can capture screenshots, send them to someone for evaluation, et cetera. The third category is infrared viewers and viewing cards. And some of these, there's a fiber view scope that you can actually, like a gun, look at a fiber in and that, and it'll tell you if it's transmitting infrared light. Very usable. You do have to use them properly, and that most of the time I see these used more in manufacturing plants and in user types. And if somebody wants information on any of these categories, I'm going to give you my personal email address at the end of the session as well to ask for more details. And then the viewing cards, if you look at the photo on the lower right, here's a small card put on a keychain, and it has an element of phosphor on it. And if you put this in front of an output of an optical device, it will actually glow and show that there's optical power being emitted. Now, there's much larger cards. This is a small one, and that has only a minor amount of phosphor. But if you want a larger area of phosphor to identify these, they cost more. But it's a good card, good to use. But they do have to be charged prior to using. In other words, you have to put them out in light and charge them up. Then they will actually react to the optical output. Again, watching out for DWDM systems because the multiple lambdas that are out, the EDFA lasers, which are typically in the Class 3 category, the Raman lasers, which can boost up to Class 4 levels. And then I mentioned on the fiber to the home systems, even though the transmitters on fiber to the home systems, most of them are Class 1 from the optical line terminal and upstream from the optical network terminal, the automatic power shutdown benefit from the residence. So if anything's unplugged, it just shuts the power off and that. So in general, lasers and optical amplifiers can generate dangerous levels of optical energy at their outputs, but they can also create quite a bit of energy away from the actual output of the amplifier. And this can be a problem during, say, a restoration. When you're dealing with extreme high power levels, when the fiber's broken, for example, during a dig up or an outage, the fiber's fractured, and that all the light energy's refracted in just about every direction. It's not a problem. But the second that fiber's cleaved, then all of a sudden we're now directing the light based on the core size and mode field diameter and the numerical aperture of the fiber, and again where the technician is. So even in this case, we don't want those technicians looking at the fiber straight on. And fortunately, with most splicing disciplines, the splicing occurs from everything's at an angle, 90 degrees from where the eye is, so it should be a little better. But they need to be aware. And again, if the transmission equipment has automatic power shutdown or automatic power reduction benefits, then the system should turn itself off. And normally in these cases where they have APR or APS, there's handshaking occurring out of band at a different wavelength at a lower data rate, and it's actually where the transmitter will be on, but it'll be at a much reduced power level until synchronization occurs with the receiver. And then at that point, once the fiber's restored, the power level will step back up to its operational levels. And again, as I mentioned, the digital scopes as shown will show you a magnifying image versus the actual optical image. So what I wanted to show on this next chart was the basic classifications, and these come from the IEC 60825 and the AN.1, and the ANSI Z136-1 standards, and these specify the classes and so forth. Now, if you didn't know, M stands for magnifying optics, R stands for reduced requirements, and B just happens to be a sequential number where the prior standard would have been a 3A, this one's a 3B. So you have the four basic categories, then you have subcategories that apply. And the risk or injury applies to each of these different types, and again, these are specified in the IEC and the ANSI standards. And you should be referring to those in much greater depth than we're able to cover in this presentation. But the risk levels listed to the right, and you can see that where we're concerned about in communications is basically the Class 3R, 3B, and Class 4, and that which are basically your EDFAs and your Raman amplifiers. The Class 2, M, is any Class 2 is a visible wavelength. So when we're talking about pointers or fiber tracers, this is what we're talking about. The Class 2 is typically a 1 milliwatt. The Class 2M is a 5 milliwatt. I know with my experience when I'm trying to troubleshoot a fiber span, I like using the 5 milliwatt version because it's brighter, it has more intensity. I'm not looking at it straight on, obviously, but I'm looking at it for macro bends or alignment or failures at a pigtail or a jumper or a nearby splice, and that's where these are really usable for. On the other side, the Class 1, which is traditionally used in normal operation or relatively eye safe. But again, you need to verify the power levels and that for these. And the next chart gives you what these are. So in this case, we went down as far as the visible red spectrum, which would be a Class 2 laser, the power levels associated with them, and then stepping through the standard wavelengths that we tend to use in fiber optics, and that from in both a milliwatt level and also in a dBm level. So let's change gears and talk about working with fibers themselves. One thing that I found real early on in fiber was I prefer working with glass fibers against a surface where I can see them. And one of the things I worked with from my first days of fiber was using chemical resistant, non-reflective black surfaces. And this applies whether it's a workbench, a cable table, or a portable mat. All these work very well when I can see the glass. And the reason is that when you're scribing fibers or working with fibers, you hope to always capture every piece of fiber and discard it safely. It doesn't always occur. Sometimes fibers end up on the surface, and with a black surface, you can contrast and see them. And so it's recommended. In the picture, you'll see a little fiber safety container, and there's quite a few variations of these out in the industry. And So this is one that has the top that opens and you put the fiber in. I can also, though, tell you I've seen different cases where going to different locations where fiber chips are sticking out of the end, and so the possibility exists that while I'm transferring a piece of fiber from the working environment into that container, I could actually get poked by another fiber. So I always try to make sure to tap them down and that make sure the fibers go into the container, and if the container gets filled, then it needs to be emptied. And when you empty a container, you have to be concerned about where that debris is being put. An example, in our lab here, we have it so that the janitorial service is not allowed in the lab area, and that we don't want them pushing down on the garbage, and everybody sees this, where someone will push down the garbage and compress it. Well, in this case, if we had fiber chips, that person would get fiber chips in their hand, or could potentially. So we don't even allow them into the room. And that we make sure that the people working with the fiber are responsible for the safe and proper disposal of the debris. So do take care of this debris. And one of the worst cases I know of is a case where someone was using a foam pad. The fiber was sticking up through the pad, and the person put their hand down on the pad, and it penetrated through literally about a half-inch of skin. That person had to go to the hospital to get that piece of fiber removed because it fractured in a couple places, and it had to surgically open up the skin and pull the fiber fragments out. We don't want to see that occur. We really want to make sure that the working area is safe, that the proper disposal is taken care of. I think anybody that works with optical fibers will probably admit that they have had a fiber chip in their skin at some point. It's part of the nature. We minimize it as much as we can. I know from my personal experience that I had one because I picked up a tool improperly. It was my fault, but there was a piece of fiber still in the tool, and the way I picked it up, instead of by the handles, I picked it up by the end, and I ended up with a fiber chip in. I learned that lesson and said, okay, proper tool handling is very important. Another element here is the safety glasses, and that to make sure you have the right safety eyewear. And there's two categories here. There's the safety eyewear that most people will use when working with fiber, that prevents fiber chips from flying into the eye during a scribing or handling procedure. And then there's the laser eyewear, which we'll talk about a little later on, specifically in personal protective equipment. So you really want to make sure people have the right eyewear for the application they're working in. The other is taking a look at where you're working and the type of surfaces, including the floors, because if materials are being dropped onto the floor, then it needs to be swept up and disposed of. The worst floor is raised floors where they're pressurized, such as in computer hubs and rooms and that, because in this case now you've got a piece of fiber that can literally be blown anywhere, and when somebody opens up a floor tile, that piece of glass can come flying out, and they're, of course, probably not wearing safety glasses. So this is where it's really critical for contractors working in these data center and type environments to be especially careful about fiber debris. And again, it should be just noted, there should never be food or drink around where someone's working with optical fibers. Now, I also want to let everybody think about one thing. What happens when you wipe your eye? You take your glasses off and you wipe your eye. Well, what happens if there's a piece of fiber on your skin? So it's a case of letting the technicians know. It says, what's your procedure? Before you do anything with your eye or your mouth, you wash your hands and making sure that there's no debris on it. I have a little habit when I'll hold my hand underneath a light and I'll just turn it slightly, because if there's any glass on my hand, the light from the overhead lights will refract from that or reflect from that, and I'll see a little reflection. It's just a habit I've gotten into for decades, and every time I work with it, it's just a little safety mechanism I built in. Okay. So anyway, take care of this. These little concerns about the safety environment here. So here we're showing a splicing vehicle, two splicers operating. If you notice, the surface is a dull black chemical resistant surface. They're fusion splicing. So what they're doing here is they're preparing the optical fibers, which means they're stripping the coatings off, and then they're cleaving the fibers, and then they have to safely dispose of the fiber chips here. And I mentioned before about dropping fiber on a floor. There's also a case of dropping fiber on your lap or your pants, so you do have to be very careful with where the fiber debris goes. Don't assume it's only on the table and on the floor. It could be in worse places. And again, paying attention to eye safety, the thing is here is neither of these two technicians are having safety glasses on. That's up to each organization on their policies. We recommend the use of safety eyewear, but you can't make somebody do it if they're not employed by you, but it's still a good recommendation. Keeping the skin, clean, washing, and again, we're watching the preparation process. I did want to talk a little bit about cable preparation, though, and tool handling. I mentioned the tool handling, making sure the tool's clean because fiber chips can still be in tools. And the cable preparation is one time I got a piece of fiber debris in my shoulder because I was walking by a reel of cable, and the end of the cable was not sealed properly. And it was out, and I rubbed against it the wrong way, and I ended up with a fiber chip. Fortunately, it was at a location that was easily taken care of, but I learned a lesson then to say, let's practice always sealing the cable ends. So, again, with dealing with eye safety, the optical power, the time exposure, how long you're exposed to the beam, and again, the fiber portions, the core diameter, the numerical aperture in the case of single mode fiber, the mode field diameter, how far the fiber is from the end of the fiber to your eye, because fortunately the numerical aperture, the spatial spread of light as it exits the fiber, will actually make it safer for the user. The closer the fiber is to the eye, the more power would be absorbed by the eye itself. And then again, consideration with high density applications that involve ribbon fibers and specifically ribbon connectors, such as the MPO, MTP types. And a reminder that the shorter the wavelength, the more dangerous the power actually is. So here we see some outside plant discipline. Here we see actually it's a transition where the cable's being pulled underneath the roadway. It's transitioning from an underground across the aerial across the street underneath the road, and then it's being pulled out of a confined space. And in this case, you see everybody in hard hats. You see a couple with reflective gear. It's hard to tell the shoes. Hopefully they're hard steel-toed shoes. There's no ventilation going on with the confined space itself, which is a concern. But there are safety standards and codes that apply. The IEEE and the National Electric Safety Code standards, the IEEE standards and the National Electric Safety Code cover safe handling and installation as reminders. There are hazards in cable placement, the heavy equipment, which means whether it's a backhoe or an auger or a bucket truck, that you have specific safety requirements for each category of equipment. Cable under tension. I've seen a 600-pound pulling breakaway swivel break away, and when you think that that cable's under tension at 600 pounds, when it gets to that point, the safety pin will break as it's designed to do. But that cable's going to be whiplashing in both directions once that breaks, and you do not want to stand in line with cable during an installation. And you also need to pay attention to what's going on around you, as well as your co-workers in place or anybody just observing in that as well. Ladder safety is part of an installation process. It's unfortunate the amount of people that break legs in that or fall off ladders in that, and it's its own category. And proximity to high voltage. You don't have to touch a phase conductor to be electrocuted. You could be close to a conductor and be electrocuted. And when we're talking about confined spaces, there's electrical cables in confined spaces. So water in confined spaces is a problem. Proper barricades and supports for trenching, and that where how many times a year do you hear of somebody who died because a trench wasn't barricaded properly and collapsed on them? And again, confined spaces, which is another ANSI standard, the ANSI Z117, I believe. And then just hazards in stripping and preparing cables, which again, the tools, the force of the tool, pulling away from you, not pulling a tool toward your chest. Metallic cable elements such as armoring or strength members, and that can be sharp. And then again, the safe disposal even of cable waste. needs to be considered as part of a safety program. And in this case, we have a technician ringing a cable in preparation to do an OTDR acceptance test. Good news is the end of the cable is sealed, and that what they're doing is an initial ring cut to set the depth of the cutting tool before they cut further up from the cable to get access. But anything sharp, knives, tools with blades for jacket removal, making sure you're covering the proper techniques of tool safety, tool handling, tool procedures, dressing armored cables, and again, after you're done with an acceptance test, make sure the cable ends are sealed. And the shrink caps are nice. Most of the time I just see electrical tape put on the end. I'd like to see them all with the professional caps, but the real world is seal them, and that makes sure they're taken care of, and then the removal of the debris as well. When we deal with chemicals, we have different types of chemicals used. Alcohol is just an example of one that we use for cleaning the fiber coatings and fibers themselves after the coating's been removed, also for cleaning V-grooves and splicers, etc. A whole variety of different types of adhesives and epoxies used, and terminations and sealing. There's cable gel removers out in the industry for ducts and so forth, and lubricants used for making ducted installations easier to perform. Anytime you hear the word chemical, though, you should be thinking material safety data sheets, and these are to be kept on site for inspection. Now, one of the things we do as a training company is, because we're holding classes nationally and internationally, is we ship basically our MSDS binder to every class, and it's there for us should we ever need it. The best MSDS book is one that's never been opened because it hasn't been needed, and that means doing a good safety program and following through is very helpful. So, but the right to know information is what the MSDS is all about. There's 16 categories in an MSDS sheet. Each of those has different criteria. They must be available. The good news today is you can download most of these from the manufacturer's site. Most of the time you'll get them from the manufacturer, but distributors are also in positions to forward material safety data sheets as well. The key point is to have them and have them available, and that means for those that are doing outside plant work and you're doing truck rolls or so, there should actually be an MSDS worksheets in that vehicle so that if anything occurs, that technician can look at that MSDS sheet very quickly and figure out if they need to flush their eye, if they need to go to a doctor, or what type of resolution needs to be applied immediately. And that, so they make sure that you keep in touch with your safety officer at your organization, and whether it's human resources or direct supervisor, but review MSDS sheets and make sure that you're clear with them. The other thing is sometimes question whether something is a chemical that you have. For example, whiteout in an office environment for just doing typos. It's a chemical. You have to have an MSDS sheet on it. If you're talking about the powder that's put in loose tube cables, that's a chemical. You have to have an MSDS sheet. If you're looking at index matching gels and splices and that, it requires an MSDS sheet. So a lot of things that you don't normally think about, you should. But even if something, if you have your child visit the office one day and you find them sucking on a highlighter, well, guess what? That's a chemical. You need to know what's important about it. So think about the different elements you have and make sure they're covered in that. And what we do is every year we do a review of our MSDS binders. We're always paying attention if something new is coming in, if it requires it, but we also want to do an annual review, top to bottom, regardless. Okay? So keep in touch with your safety officers and make sure that, or your supervisor, and make sure that you're current. And some of the different types of chemicals are shown on this page, but solvents as well as adhesives. Lubricants, one of the things with lubricants, it's not just that it's a chemical, but if you spill a lubricant, they're designed to ease friction on cable pulls. They're also extremely slippery if somebody steps in them or around them. So, if you end up with a spill of lubricant, whether you shovel some dirt on it, some kitty litter on it or something, barricade it off, but keep people away from it, clean it up as soon as you can, but don't have an accident happen just during normal operations because we didn't take a few minutes to correct the action or the problem. And then some of the other elements is when chemicals are being transferred from, say, a larger container to a smaller container or to a syringe or so. And then the proper mixing of chemicals, what compatibility, disposal. You also have to make sure whenever you're dealing with chemicals that we're dealing with ventilation, and ventilation at the bottom under PPE. The PPE category is dealing with, for example, breathing apparatus, but it can also apply with chemicals and the air quality in your working environment. As far as personal protective equipment goes, eye protection, gloves, and ventilation are three categories. There's many more. With eye protection, we're going to talk also about the laser power levels and the different types of laser eyewear. And then gloves, I recently got a sample of gloves that are meant for working with, so you have a really good tactile sensation in your hands, has a rough edge over the fingertips. We're trying to work to see, okay, can glass penetrate through this, to what degree, and whether they're safe, and I'd love to get a notification out if we find this is the case. Officially, OSHA's stance on this is that if glass can penetrate the skin, then you need to wear gloves. On the other side is if you see virtually any technician in the field, none of them are wearing glass during fiber preparation because they need to feel the fiber and touch it and that for it. So the glass works against them on being productive. So we have kind of a quagmire here between what OSHA's saying and the reality of working with fiber. And we'll see where it goes. Hopefully, though, we'll see some good safety gloves out in the near future that are designed specifically for fiber. And then ventilation leads us into confined spaces. And and again, confined spaces is working with installation practices. Here we see a duct being installed into a manhole, and you can see a ladder in the manhole. You can see the ventilation occurring. In the shot here, there's no barricades around it, which is a normal requirement. Everybody is wearing a hard hat, and 2 out of 3 have a vest on. I take the third one's probably a supervisor or so and isn't going to be overly involved, but he probably still should be on the work site. But again, as I mentioned, mechanical tools, watch out for cable under tension, any device under tension for that. Watch out for moving parts. You've heard or seen different signage about people with long hair or so need to be put away or so because, or loose clothing, anything that can be caught in the capstan or so. It could be a fatal injury in that, so you want to be extremely careful. I also want to mention that your organization has basic safety practices and there's company policies. Nothing that we're saying here in this presentation should supersede any of these standards, and that if you need clarification, I will be giving you my email address at the end. But at the same time, we want to make sure that if you have questions, to bring them up to your safety officer and supervisor, and make sure that your concerns are being addressed. I also wanted to mention that Telcordia has a special report, 1421, called the Blue Book, and it's titled Manual for Construction Procedures. And it has quite a bit of guidelines for safety and proper setups, handling during the installation and construction process. I find it to be extremely helpful and that to use. Now, the confined spaces category, the definition of the confined space is listed in the ANSI Z117.1 safety requirements for confined spaces standard. And so I do recommend that you put this into your safety program if you are involved with any type of construction that deals with vaults or manholes and such. Some of the items that are included can deal with gases and gas monitoring. So there's not only the combustible gases, but there's, for example, oxygen. Is there enough oxygen in the space in that for someone to breathe, or will they literally go unconscious? There's also toxic gases, such as carbon monoxide and hydrogen sulfide, that need to be identified. And when you look at the monitoring equipment, you need to make sure that all the functions that they're listing are compliant with at a minimum of the Z117.1 safety requirements. And then again, the ventilation requirements. No flames inside or within a close proximity, and this is one of the reasons why we don't fusion splice inside a vault or manhole. We take the cable and the closure outside to a splicing vehicle or location, and we splice, because there can be combustible gases, and it's critical why we ventilate. So, but it also means no spark-producing equipment, too, so if there's electronics. The picture, you'll actually see a harness and a device where the technician that's actually down in the site, there's one up, one down, and where we live here in Washington State, we have a regulation where there has to be one up and when there's one down. And then the person has a harness that's attached to a winch up top, and if needed, the person can winch that person up and out of the confined space. In this case, he's got partial barricades that wouldn't keep somebody from walking in or around, so he's got to pay attention to this. Again, always testing prior to entering, and then watching out for things like water in vaults and manholes due to electrocution and occasionally drowning. Okay. Another category is just when people are under stress, safety can be another concern. And emergency restorations is an example of this, where they're working against the clock to resolve a problem. And because of this, there's pressures put on. A lot of times you're not dealing with the best weather conditions. Matter of fact, it could be where an aerial structure came down because a tree collapsed against a pole or a line. So you've got tree damage. Of course, you should never go even to this restoration or start the restoration till you can confirm that there's no electricity. In other words, the power company has shut down the power on the phase conductors prior to any work being done in the communication elements or segments of the pole. Watch out for high voltages, power lines, static charges, and natural disasters. You can have landslides, you can have washouts, all sorts of different concerns on an emergency restoration that cause the outage. Well, the cause is still there. You may not be completely resolved yet. So don't send anybody into an unsafe environment until it's cleared and ready for them to do the restorations or repairs. Also, I want to add in here vehicular safety, because where there's a restoration, a lot of times you're working on the side of a road or in an area where there's still traffic, and traffic management's critical. And if needed, call in an emergency crew and that for traffic management with signage and barricades, and if necessary, police officers or so to make sure to manage the traffic while it's being handled properly. Back to laser eyewear. So if you are dealing with lasers, there's a lot of different types of safety eyewear specific to different types of lasers. And when you look at one of these, on the eyewear itself, is it will give you information such as the optical density level, or OD, and that level will tell you the attenuation factor at a specific wavelength at which the beam power has been reduced. And that, I just happen to be holding one in my hand right now, and it has an OD level of 5 at 1064 nanometers. And again, this isn't a standard wavelength used for communication. It just happened to be the first one I grabbed. And then there's a warning, never look directly into the laser beam, and gives additional information. But the eyewear comes in different types. You can have it where it completely seals around your forehead and around your nose and your sealing off your eyes. And the reason is, on a high-powered laser, you could get reflected energy coming off a ring or a watch, and that would be high enough to do eye damage. And we're talking class 4 lasers here where we're really concerned, but even the class 3. Other type of laser eyewear may be more comfortable, but they may not be fully engaging around the skin as well. You also, of course, you have to deal with the different clothing and breathing and that on apparatus, but let's stay on laser eyewear. So what you need to do is define the wavelengths that you're going to be inspecting, and then make sure that anybody that's involved with that has the right personal protective equipment. This could be the right type of safety laser eyewear involved. It could be the power meter, it could be the fiber view scopes, it could be the phosphor sensor cards or so forth. A lot of different tools that apply, but at some point, if you're involved with it, you need to make sure that you have the right equipment for that. And then clothing, I mentioned steel-toed boots and reflective gear and such. That would be PPE. Breathing apparatus in confined spaces as well. So we're done with the topics at this point in the amount of time that we had to present this. In our next webinar, we're going to address passive optical devices, but we've got quite a few more webinars to do, and so depending on responses, comments, and if there's a need, we could expand more on any one of these elements and expand it to another webinar topic, which we've done in the past. I did mention that I was going to give you my personal email address if you have questions, and I know we have some questions queued up as well. So I'm going to hand. We have some questions here. So one of them here is the practice of using black tape to put fiber chips on. And so in this case, I don't know if any of you have seen this, where someone will take electrical tape and they'll reverse wrap the electrical tape and put it on a surface, and then all their fiber chips, they stick to the electrical tape. And am I a proponent of this technique? And the question is, no, I'm not. And here's the reason, is that eventually somebody has to take that electrical tape off the surface it's adhering to. They have to then dispose of it. The problem is the electrical tape's sticky, so what happens, now you've got fiber chips on a sticky surface. You have to now put that surface, even though you're reaching on the inside, the fiber chips can still poke the skin, and you can have skin damage in that for it. Another question was, how do you remove a fiber splinter? And in that case, years ago, I found tweezers that if I had them coated in Teflon, I'm talking late 70s, early 80s, that if I had Teflon coated tips on them, that it wouldn't break the glass. It would actually be able to hold the fiber, pull the fiber out, and this way you could dispose of it. There's several manufacturers now who make fiber optic safety tweezers that use the Teflon coating at the end. I do recommend that anybody working with the glass fibers has the safety tweezers as part of their safety toolkit. And one other thing is if the Teflon is removed over time, replace the tweezers. $10, $15, I don't know what they cost, but it's a negligible cost versus having somebody away from the workforce for some time. Let's see. Will laser eyewear protect while viewing through a microscope on the live fiber? Yes, and what you have to do is making sure, number one, is that you're specifying your laser eyewear for the specific wavelength that you're checking. Number one. Number two is making sure that the optical density level, or OD level, is adequate to step that laser power down far enough so you basically bring it down into a class 1 level, and that for it. The secondary portion of that question is, when you mention through a microscope on a live fiber, is to make sure that your microscope has the built-in laser filter, and most of those over 200 power do, but it's really recommended that you go back to the manufacturer and ask them to supply you the laser safety chart and that for that microscope, so that you have it available. And you'll see that it varies with wavelength, so that an 850 or 1310 or 1550 will have different levels of filtering occurring, but you do need to have access to that. Okay. Is there a written standard for different types of outer jacket, armor, and maximum pulling force for fiber cable during installation? Actually, the values are specified by the cable manufacturer, which will give you two different levels of tension levels that can be pulled for the cable, and one of them is during the installation itself, and the second is post-installation. And the reason you could have tension on a cable after the installation, it would be a case of aerial installations where just the span distance and the sag and the weight of the cable will always have tension onto it. So, but that should come from your cable manufacturer, but there are specific standards put out by the TIA and the IEC that specify different cable types and structures. I would think that Telcordia also has the same, but I would have to verify. But again, email me directly and that on any of these specific questions. I'll be glad to help you there. So how much pull force can be applied to the fiber? Is it really that vulnerable? Well, the fiber, most fibers today have a tensile strength of 100,000 pounds per square inch. So what I found is I cannot break a fiber. I can wrap it around my hands and that and pull in both directions, and I cannot break it with my own physical strength at it. It's extremely strong. However, if I start jerking it back and forth and whiplashing it or so, I can cause the fiber to break. Most of the time where a fiber is going to break is going to be against an abrupt surface, a 90-degree turn, or something that causes the fiber to break, but it's extremely strong. Let's see, are there fusion splicers or alternatives approved for use on aircraft? You know, I'm going to have to check on this. I remember in the past there was a fusion splicer that injected an inert gas into the area where the electrodes discharge, but I would have to go and check with the manufacturers for that. But there was specific, and I remember you know, dealing with this issue, but I have to say it's been well over 10 years since I addressed it, and I'd have to go out and make some questions itself. So let's see, does a white work surface increase the danger in a fiber splicing environment? Yes, and the reason it does is you can't see necessarily, for example, one of the color codes in fiber is the white, so you wouldn't see it against a white surface. I just found that historically I can contrast against a black surface, but even black is one of the standard 12 color codes too. I would just be extra careful when I'm dealing with those surfaces. And the nice thing, if you have a white surface, the cost of replacing it can be a little high, but there are some little placemats that are black chemical resistant that are available that you could put over the white surface that would help you with the contrast for it as well. Okay, so let's see. My understanding is that the APC used in FTTH ensures rapid dispersal of the laser light. You are in a greater danger of poking yourself in the eye because you would have to get that close. How far from an end before one is eye safe? First thing, the angled physical contact, which is what APC stands for, is an 8-degree angle. And I've never heard of anybody poking themselves in an eye with a connector. In one case, you don't even want to look at the end of a connector with an eye. You know, if you want to be using a microscope anyway. And the inspection scope, you know, would be looking, and again, we want the safety filter in the microscope, and if it's a digital scope, then you don't have to worry about the filter because you're only looking at the image of the in-face. So, you know, but you shouldn't be putting any connector that close to your eye for any reason. If you want to look at a connector and look at the ferrule, the inside diameter of the ferrule or so, you can look under an eye loop or so, but it's going to be hard to hold it steady and be able to look at the end. You can also look at inspection equipment such as interferometers, which can show you the profile of the fiber end face a lot easier and safer than it would be to try to do it mechanically in your hand. Okay, question, what type of classification would apply to lasers that are terminated with the expanded beam connectors or other collimating optics? Well, number one is first is you have the laser itself being coupled prior to the connector. So if you're doing terminations of an expanded beam connector, you're first dealing with the laser power prior to it, and again, the cleaving of the fiber. Because the expanded beam contacts that are typically used are connectors. You're dealing with a cleave, and then you're putting that into the end. But because it's normally a flat end face, which is highly reflective, there's a good chance there's index matching gel in that will also reduce the reflection and as well. But you would have to go to the the expanded beam, the manufacturer of the expanded beam contact or connector. And most of the time, these would have anti-reflective coatings onto the ends as well. So you would have to ask them what their safety recommendation would be and what the power levels would be for it. But that would go back to the vendor. But the laser level does not change prior to the connector. It changes in the connector. And you would have to ask them specifically what their specification is. Question, is it possible for a small fiber splinter to migrate into the bloodstream and cause an aneurysm later? People say this and that, but I've never heard of a single case of this occurring. And even when I've had fiber splinters, they're relatively large. We're not talking granular like a piece of salt, a grain of salt or so, but I imagine they could be. But in every case where I've had a fiber splinter, it's been one that I knew it was there, and in almost every circumstance I was able to safely remove it with the fiber optic safety tweezers. And I had one where it just was right under the surface and it just worked its way out. It didn't work in because the skin grows and that for it. I did admit it was an irritant for a while. One thing, though, with the fiber is, they normally don't come in at 90 degrees. They'll come in at an angle. And then when you rub against it, I literally had one where I didn't notice it till like about a day later, and I rubbed something, and all of a sudden it rubbed the wrong way, and all of a sudden I go, oh, what was that? And then I did my little trick of putting my hand under a bright light. And then I saw the reflection occurring off of it, and then I was able to see it and then pull it. So at this point, we're closing. My email address is larry@lightbrigade.com, and I need to hand this over to Jim for the final discount feature special.
Thanks, Larry. That's an awesome amount of information there. It's unbelievable. Just a reminder, I put the slide back up about the discount for the DVD on safety. It covers what we covered in this class plus a lot more, and we're offering it at 20% discount, so it costs you $99. You need to list the Lightwave June Safety as your discount code when you order it, and we'll take care of that. For a full description of all of our classes and materials that we have available, please go to www.lightbrigade.com. And for support questions, that's support@lightbrigade.com. And we included both our phone numbers here. I think, Larry, you mentioned your email address is larry@lightbrigade.com for additional questions there. We thank you for your participation today. And again, you can watch this again or tell your friends they can watch it at Lightwave Online on demand tomorrow. And we have 4 additional webinars that are already up there, and we invite you to come join us next month for our webinar on passive optical devices. Thank you very much.